been traveling across space for thousands of years by the time it reaches us here on Earth. Some of those stars that you can see tonight in the night sky may have burned out thousands of years ago. If you have ever wondered where stars come from, how they change, and what happens to them when their life comes to an end, hang with me for a few minutes as this episode of NASA Launchpad takes a closer look at the life cycle of stars. And, bonus, we're going to talk a little bit about how each of us is actually made from dead stars. Yeah, really. Most things in the universe have a life cycle. Thankfully, for some things, like these guys, the life cycle is incredibly short. But for other things, like stars, the life cycle can be billions of years long. The life cycles for stars begin in giant stellar nurseries called nebulae. If you look at one of these star-forming nebulae, you will see beautiful giant clouds of dust and gas. How a star forms is a little technical, so let's hear an explanation from an expert.
A star is basically a nuclear furnace. It's this collection of mostly hydrogen gas, and at the center is really, really hot and dense, where you can actually get nuclear fusion occurring, and that's how you get the heat and the light from the star. In space, you have this collection of sort of diffuse gas and dust particles. It's just sort of everywhere in space. Occasionally, it comes together through gravity. It's attracted to itself, basically. And so you get these giant molecular clouds, they're called, these big nebulae. As that stuff comes together through its own gravity, you eventually get these places where you have enough material where you can start to form a star, where it all comes together and the gravity pushes on it so hard that it heats up in the center, and that heating up is what will eventually lead to fusion and the birth of a star. Two of the most important properties of a star are its color and its brightness. And so if you take stars and you sort of sort them by color, you get anything from red to blue, where the red stars will be the cooler stars and the blue stars will be the hotter stars. So that's really a measure of temperature. And then you can also sort them by their brightness. And so you have the very bright stars, which are usually the more massive stars, and the dimmer stars, which are usually less massive. And just by these two parameters, you can actually tell a lot from a star. You can tell how massive it is, you can tell how big it is, its radius, you can tell how old it is, you can know what stage of evolution it's in, and you can learn about the environment of the star, that the star was born in.
As you know, our sun is a star. It is actually a fairly modest-sized star. It is believed that our sun is about halfway through its 10 billion year life cycle. Yes, that makes our sun about 5 billion years old. But don't worry, we're all good for at least another 5 billion more years. So, how will our sun's life cycle play out?
So our sun is a low-mass star, and it's actually going to go through a really long evolution. It's going to be in the phase that it's currently in, where it's just fusing hydrogen into helium, for about 10 billion years. And then once it runs out of fuel in its center, it's going to evolve into a red giant star, a red meaning that it's going to be cooler, and it's going to be so large that its outer radius is actually going to reach the Earth's orbit. It's going to be a huge star. And then eventually it'll blow off its outer layers and become a white dwarf star, and that will be its final phase.
So at the end of a massive star's life, we have what's called a core collapse supernova. So the core region collapses in on itself, and the outer region infalls and then rebounds, and you get left with a neutron star or a black hole.
You may have noticed that no matter the size of the star, at the end of its life cycle, most of its material is expelled back into clouds of dust and gas in the galaxy. The life cycle of a star can begin again.
Throughout a star's life, it's throwing off material, and this material has been enriched by nuclear fusion reactions. So originally, really only hydrogen and a little bit of helium was produced in the Big Bang. And all of the elements that we get after that have been produced in either a star's life or in its explosion, if it's massive enough to explode. And that material gets mixed in with the other gases and dust in the interstellar medium and produces the next generation of stars. So every generation of stars that you produce is more and more enriched with material from the life and death of stars.
So what does all of this mean for us? And what is our connection to the cosmos?
All of that fusion that's going on in the centers of stars is creating heavier and heavier elements, and that's how you get basically everything you see around you, from the carbon to the iron, the oxygen, everything. You can't get any of those elements without having a star forming it in the first place. And so everything that your body is made up, everything that you see around you, all came from the center of a star.
Pretty amazing, isn't it? When you look at that periodic table hanging in your science class, it represents all of the natural and man-made elements. Most of those natural elements were formed and fused inside of long dead stars. Yeah, that's right. Almost every element in your body came from the inside of a star that died billions of years ago. We may look and act differently from each other, but we are all made up of the same stuff. Want to find out more? You can learn more about stars and their life cycles from these NASA websites. That's it for now. See you next time on NASA Launchpad.